Okay, here's another application of derivatives of periodic functions. The population of a colony of frogs rises and falls according to the breeding season. The population can be modeled by the function, this function, where t is the number of months since the beginning of year. Now, part A has nothing to do with derivatives. Find the population at the start of the year. Just let t equal 0 and solve. So part A is really simple. Just put 0 in where t is, and you'll get an answer pop out on this side. What I wanted to look much more in depth at is part B, the first time at which the population is greatest. Okay, so we have a function that looks like this. It's a sine function, and it probably goes up and down, up and down. This is the point where the population is going to be greatest. Now, the reason this has anything to do with derivatives is because at any of these turning points, here or here or here, you're going to have a rate of change equal to 0. Okay, you can see the gradient of each of these lines is 0, which means the rate of change at those points is also 0. So if I can find the derivative of this function, p dash t, that equals, let me have a think about that one. Okay, that equals 100 times pi on 2. So pi on 2 is just the number there that comes out of here. Cos, and then the brackets stay the same, pi t on 2. And that 500 is going to disappear. We can just tidy this up a bit. That's going to be 50 pi cos pi t on 2. Now that we know what the derivative is, remember we want to know a maximum, so we need to let our derivative equal 0. So let p dash t equal 0. So 0 equals 50 pi cos pi t on 2. Now you need to think about this one just a little bit. 50 pi cos pi t on 2, that's 50 pi times cos pi t on 2. That's only going to equal 0 when cos pi t on 2 equals 0. So we just need to find out when this occurs. 0 equals cos pi t on 2. Okay, it's a good start. Now you're going to have to find at least two answers to this, reasons for which I'll explain in a moment. Now, cos equals 0. Cos equals 0 at pi on 2. Cos equals 0 at pi on 2. And then the next time cos equals 0 is at 3 pi on 2. So that means that pi t on 2 equals pi on 2 or 3 pi on 2. Now, one of those answers is going to be a max, and one of those answers is going to be a minimum. We just need to figure out which one's a maximum and which one's a minimum. Before we do that though, let's just solve it for both. So if pi t on 2 equals pi on 2, that means that t equals 1. So there's one answer it could be. The second answer is that if pi t on 2 equals 3 pi on 2, then t equals 3. So we have two distinct possibilities here. And again, t equals 1 might be a max or a min, and t equals 3 might be a max or a min. Now, you should remember this from last year. It's very annoying, but it's something you're going to have to be able to do. Oops, bring my table over here. You should remember this stuff from last year, I hope. This is the first derivative test to check whether something's a maximum or a minimum. So we can do t of 1, 0, and 2. Now we know when t equals 1 that p dash t equals 0. Okay, we just need to sub in t equals 0 into p dash t, and we need to sub t equals 2 into p dash t, so into this. And when you sub that in, I'm not going to sub it in right now, but when you do sub that in, you'll get 50 pi on this side and negative 50 pi on this side. So I'm just subbing in 0 into p dash t. Where's p dash t? There's p dash t there. And then I'm subbing 2 into p dash t. Now that's a positive gradient here. That's a 0 gradient here, and that's a negative gradient there. Now that means that that's going to be a maximum. So t is going to be a maximum. Now you could do the same thing with t equals 3, but because we know that t is going to be a maximum, then that means the next one's going to be a minimum. So the question was asking us the first time at which the population is greatest. It's at time equals 1. It's actually in January. Okay, lots of work there, some fairly complicated stuff to get through. Make sure that you talk to me if you're having any trouble with it or you're not sure about how to go about it.